All right, welcome to today's lesson. Before we get started, I want to remind you that you should be taking notes either in your notebook or on a piece of paper that will later go in your math binder, but you should be taking them somewhere. And at the end, when you are done, you will be asked to show them to me in order to receive the homework assignment. So please make sure you are taking those notes somewhere. Today, our objective is that we can find missing lengths in similar figures and use similar figures when measuring indirectly. So first we need to know what similar figures are. Similar figures have the same shape but not necessarily the same size. So we might be looking at two rectangles, we might be looking at two triangles, we might be looking at two circles or octagons, any shape. However, they are not going to be the same size, but they will be proportional. So there will be some connection between the two shapes. So with that in mind then, when you heard me say they are proportional, hopefully you recognized the word proportional from yesterday. And knowing that, we can use our proportion knowledge from yesterday to find those missing lengths. So anytime you have similar figures, you can use proportions to find missing lengths. So if we take a look here at this first problem. So the first thing that I see two triangles. I see triangle ABC and triangle DEF. Something I do want to point out, this little squiggly line symbol here in the middle, that is the symbol to show ABC is similar to DEF. So at this point, we don't have to determine are they actually similar or not. It is telling us they are, so that we can use our proportion knowledge to find the missing lengths. So when I'm looking at this here, I'm looking at my triangle, and when I know a shape is similar, I'm not going to say that side AB is similar to side EF. That does not make sense. They're not in the same side of the triangle. They're not connected. They're not beside the same angles. So when I'm looking at side AB, it is actually similar to side DE. Side BC is similar to EF, and side AC is similar to side DF. So once I've got that in mind, it should be fairly simple to set up my proportion and find my missing side. I will point out it's asking me to find DE, and as I'm setting up my proportion, it is extremely important to set it up correctly, otherwise I won't end up with the correct answer. So as I look here, I need to find DE, and I currently have that highlighted as yellow. I have also seen students in the past, instead of using a highlighter or colored pencils, put little hash marks to show that those are similar. These both have 2 hash marks and these have 3. That's a way to do it if you don't have colored pencils or highlighters. But that means I need to include side DE in my proportion. So I'm going to have my yellow or my 1 hash mark, and then I'm looking at my triangles and I'm noticing that they both also have the pink side measurement, so I'm going to include that in my proportion as well. So as I set up my proportion, I'm looking first at my first triangle, ABC. My yellow number is 10, my pink number is 16. Set that equal to my second triangle, DEF. My yellow is my unknown, my variable, and my pink is 12. From here, it is our proportional knowledge from yesterday. 10 times 12 is 120. 16 times x is 16x. Divide by 16 on both sides to get x is equal to 7.5 or 7.5. So my missing side, side DE, is 7.5. All right, so here on this second piece here, I have these same triangles. The same thing's already given to me, except this time it is asking me to find a different side. So I'm going to go ahead here and just put those highlighter marks on here if you would like them. At this point, please pause the video, and when you are ready to check your answer, please press play and check your answer. All right, welcome back. So let's take a look here at the answer. I need side AC, so I know that pink needs to be included. Sorry, I mixed up the location of my colors. Pink needs to be included, and I notice that I still have both of the yellows, so I'm going to include that. X over 16 is equal to 18 over 12. Cross multiply. 18 times 16 is 288. 12 times x is 12x. And when I divide by 12, I discover that my missing side length here is 24. All right, so let's continue on here. How else can we use this? We can use this when we have a map or a visual representation of something. The sun's rays strike the building and the girl at the same angle, forming two similar triangles. So right there in the problem, it's telling us that we already have similar triangles. How tall is the building? As I'm looking at this question, I see that it says 3 feet on the bottom and that she's 5 feet tall. On my larger triangle, I have 15 feet on the bottom. So there are actually two ways that we could go about solving this. The first one is with the proportion. Okay, so I am going to put in my little reminder about how to write my proportion, I'm going to put the bottom and the side just to keep my mind straight. So I've got 3 feet over 5 feet for my first one. My bottom is 15 feet in my second one, and my height is what I don't know. 15 times 5 is 75, is equal to 3x. Divide by 3, and I discover that x is equal to 25. Now, another way that some of you might have been thinking about this, when I'm looking at my image itself, I notice 3 and 15. I can go between those two values with a multiplication problem times 5. So if I apply the same multiplication problem to my other side of the triangle, 5 times what gives me 25? 5 times 5. And so that is visible right here. 5 times 5 shows me that this is also 25 feet tall. So that is a second method if you prefer that. It's not always as nice and simple multiplication, but if you see that, you are more than welcome to use that. So, something else that we see with these similar figures is we sometimes see scale drawings. So it is a similar figure or a proportional type of knowledge that we use to make scale drawings. So when we are looking at scale drawings, we're thinking of a map, we're thinking of a blueprint for a building, we're thinking of a three-dimensional model that architects make. They usually make a smaller one and then to show the client and then later make the actual size. So those are all scale drawings or scale representations. A scale drawing just means it is similar to the real thing but a different size. So the ratio of the length of the drawing is always the same. That is that proportional knowledge. In order for it to be similar, it does have to be proportional and have the same ratio to go from one number to the other. So when we're taking a look here, okay, we have a scale drawing, and I do have a map here to show you. I see down here in the bottom left-hand corner that it says the scale is 1 inch to 110 miles. So I'm already thinking inches and miles is going to be the two things that I use in my proportion. So my scale is going to be my first fraction of my proportion, 1 over 110, because that's what it tells me my scale is here in the bottom left. Then I'm going to look at my map and take a look at the measurable distance in inches from Jacksonville to Orlando, since that's what my question is asking me. At that point, I see that it has Jacksonville and Orlando as 1 1/4 inch, or 1.25 inches from Jackson to Orlando, and I don't know my miles. That is my unknown. Cross multiply and solve. 110 times 1.25 gives me that this is 137.5, and that is equal to 1x, which is the same as x. So Jacksonville to Orlando is 137.5 miles. So once again, please pause the video and attempt this problem when you have got it and you are ready to check your answer, please resume the video and check your work. All right, welcome back. So I did also take a moment there to remind us of the scale from before, 1 inch over 110 miles. And now it tells me I'm measuring Jacksonville to Gainesville and that the distance is 0.6 inches. So that is what I will use this time. 1 times x is 1x, or x, and 110 times 0.6 shows me that between these two cities I have 66 miles. Jacksonville and Gainesville are about 66 miles apart. All right, at this point you should see these two got it questions on your screen. These are the two questions. You should already have other notes written down somewhere. Some of the problems, most of them, all of them, you should definitely have a few. And at this point, I would like you to write down these two questions. When you are done with the answers to these two questions, bring them to me for me to check. And if they are correct, I will give you your homework assignment.